heated solely by post-heating or post-cooling the fresh air mass. You don't need a heating distribution system in a passive house. You need a ventilation system and a little heater in it for occasional use in the middle of winter when it's freezing outside. That is the holy grail, in my opinion, and it's there, and it's proved. That was the first passive house. The sides of the ship were lined with tarred felt, then came a space with cork padding next to deal panelling, a thick layer of felt, airtight linoleum, interesting phrase, last of all inner panelling, the ceiling, blah blah blah, total thickness 15 inches. Skylight was protected with 3 planes of glass. Gosh, triple glazing. This is 1883. The fram is comfortable. When the temperature stands at 22 above 0 or 22 below, we have no fire in the stove. 22 below. Ventilation is excellent. Since we rigged up the air sail, we had like a thing to drive air through. In spite of this, warm and comfortable with only a lamp burning. Remember that lamp? I'm thinking of having the stove removed altogether. It's only in the way. Right? That blew me away. That was the first slide they showed us on my Passivhaus course. 1883, okay? Nothing new under the sun. What is Passivhaus? It's a quality-assured energy performance standard for buildings, applicable to any building. House means building. It's a passive building. And it's a design tool which we can use from day one. When you've first drawn your little scribbles on a bit of paper and say, we think we want these houses like that, we can start to assess those buildings for Passivhaus standard. Invented by these two guys, Bo Adamson and Wolfgang Feist. Don't know what happened to Bo, he's still around I think, but Wolfgang is the man. Comes over and we all go, sir. And he lives in, and that's the first passive house, built in 1990 or 91. Okay? Being monitored continually, and it's performing flatlining all the way through. Looking at, this is Germany, standard buildings, special low energy standard in passive house. They did a lot of work through a thing called the CFIS project, 90% savings on over conventional existing buildings. And it's all about a very simple equation. I don't do maths either. It's about balancing up 4 things. The heat load, that is the losses through transmission and ventilation, and the gains from the sun and from other things. Your computer, your cooker, the dog, you. And the difference between those two is how much heat you've got to put in. So you get rid of all your losses as far as possible through the walls and through air, and you keep hold of all the gains that you've got, and the balance is small. That's all you've got to put in. It's only small in the winter. So how do we do it? So the first thing is we maximise solar gains. So we've got to design the orientation, we've got to design the site, the way the houses face, the way the glazing works and the shading. We've got to get that right. So there are some things that come in right at the beginning about that site, about how you lay that site out. And there are incidental gains going on, which we maximise, so we're saving those basically by insulating and by making it airtight. Because all those things that are using energy are part of your primary energy target. We reduce the losses, so we insulate very well. We eliminate thermal bridging, which is, if you've got a concrete lintel that bridges from the outside to the inside, heat transfers through it. Yeah? If you've got steel work that bridges from the outside to the inside, heat races through it. So it's about building a structure and wrapping it up. Think of the bucket with the holes in it. It's having a complete container. Think of a tea cosy. You've got a tea cosy that sits over the whole teapot, or you've got those ones where the spout and the handle point out. Well, the spout and the handle are like thermal bridges. The heat flows out through those because they're not insulated. So there's a sort of diagrammatic passive house. It's insulated all the way around. There's no breaks in the insulation except where there have to be for things like windows. it's got an air tightness layer to limit the air losses. Now what we're doing here is we're not sealing you in a plastic bag, we're controlling the ventilation instead of leaving it uncontrolled. Most houses are ventilated by default, gaps. Okay? Because we're controlling it, we are actually making it very airtight. The air's not flowing in from the outside naturally. We've got to manage that and manage it with a heat recovery ventilation system, which recovers most of the heat from the warm, stale air before it chucks it out and puts it back into the incoming air. And we have to have triple glazing. We can't do it without. So where you would normally have breaks in insulation, things here, and the loft insulation comes up, and there's a gap, and then there's a wall, and then some wall insulation, and there's problems here, all losses, we get rid of all those through good design. What's the standard? Okay, this is simple. If you hit this, you've got a passive house. And if you hit passive house, you don't need your heating system, you can do it through ventilation. We've got to hit 0.6 air changes per hour. Building regs is about 1, between 0.6 and 1, because they measure it differently. Building regs is 10, so it's 10 times better. We've got to put in triple glazing with U values of about 0.8 or below. Building regs 2, so it's more than twice as good in terms of the glazing. We've got to put in at least 75% efficient MVHR system, and it also has to have a low fan power. So when this is working, it's using less energy to work, much less energy than the energy it's recovering from the air.
So just to confirm, the MVHR is the mechanical ventilation?
Mechanical ventilation with heat recovery.
So that's ventilation.
How's the efficiency measured? Because there's some dispute about that.
I can't answer that. I'm not that technically competent, but there are approved methods of measuring them, and Passivhaus actually takes the calculated test methods, it then applies all sorts of other criteria, so it knows how long all the ducts are, and it readjusts and reduces for all the losses, so it actually readjusts efficiency. And the thing about the PHVP measurement method, assessment tool is that it doesn't leave anything to chance or to the manufacturer saying so. It tests or modifies everything. I can't answer that, but I can probably find you the information if you really want it.
Well, when we specify, we'll certainly need...
Well, the easy way is you specify Passivhaus approved. Passivhaus Institute test a lot of stuff, and their rules are very, very rigid, so that when they test it, they say this complies. But we can get onto that. That is no disrespect, that's a technical detail, but yeah, I agree with you. It's a minefield trying to understand that. Okay, so what have we got to hit? We've got to achieve. We've got to achieve one of these two or both of these performance levels. If you remember the phi, you've either got to get down to 10 watts per metre squared heat load, so that's how much power you need, or you've got to get down to 15 kilowatt hours per metre squared per year consumption. This was 39.45 in the phi. Now, that means at 10 watts per metre squared, a 100 square metre, 3-bedroomed house needs 1 kilowatt. Your hairdryer on half power. Yeah? Most hairdryers are about 2 kilowatts, I think. That's the heat load. That's the maximum power you've got to put into the house. It's nothing.
That's in the depth of winter.
That's peak. Most of the year doesn't need any. Same applies to cooling. So in the summer, if it gets really hot, we're not allowed to build these buildings to get hot. They've got to stay cool. And if you insulate a building well, it stays warm in winter and it stays cool in summer. It's the same figure, 15 kilowatt hours per metre squared per year cooling load in the cooling season. We've also got this thing called a total primary energy demand. That's all the energy your house is going to consume. So that includes your television, your washing machine, and it's 120 kilowatt hours per metre squared. Now you can meet the other things and stick in electric radiant heaters, but you'll miss that target because it'll kill it. So there is a complete energy standard here, which is wonderful, because if you've got this to work to, you know what your house is going to do. And most of the monitoring is showing that passive houses generally perform at or better than predicted, whereas with SAP you can be looking at twice as bad. It's not uncommon. There's an overheating rule as well, and that is tighter than the UK normal overheating rules because it's 25 degrees maximum for no more than 10% of the cooling season, which is 6 months in the summer.
That comparison between the 120 and the 15.
It's quite a lot, isn't it?
Yeah, because Wolfgang Feist actually came and gave a lecture in the mathematics department, which was quite amusing because he thought he had to talk maths in the maths department. He was showing actual performance data, and there's an amazing difference in the houses based on that the primary energy demand within the house, because that's basically what heats your house.
Yes, if you've got more devices going, your primary energy goes up, but then your heat load goes down. Because,
How's that controlled then? If you build a passive house and then stick...
You can't control it. You can't stop people putting more devices in their homes. What you do is